yeah, recognizes an A because when we consume an A, we're in a final state. It recognizes an AA because when we consume the first A, followed by the second A, we're in a final state. It doesn't recognize a B because when we consume the B, we don't go to a final state. Okay. What about AB? Okay. What should it do? It shouldn't recognize, it should recognize AB. Okay. So let's see what will happen. So when we consume the A, that takes us to a final state. When we consume the B, we should also go to a final state. So let's take this S1 into this final state over here, okay, on a B. Okay, so that's good. Okay, so now what we have is the machine recognizes at this stage the word A, the word AA, the word AB. Okay, so it recognizes our A, it recognizes our AA, it recognizes our AB. It doesn't recognize a B. Okay, so that's out. Okay. It shouldn't recognize a BA. Okay, well, where's a BA? A BA is a B followed by an A. Okay, so I shouldn't. So when I consume the B, okay, and then when I go from S0 to S2, when I consume the A, I should not be in a final state. So let's consume the A here, okay, and we remain here on an A. Okay. What about BB? Well, when I consume the B, I'm going to be taken to this state here. When I consume the next B, I should be also in this state here, which is a non-accepting state. Okay, and we can continue in this particular fashion. Okay, one of the more real, I suppose, how we know we've sort of reached the end is one of the most important things to have in your finite state machine is that on every state, yeah, okay, we have a transition, yeah, okay, associated with each one of the characters in our alphabet. Okay, now you can see here that on S0 we consume A's, we consume B's, so that's good. On S1 we consume A's, we consume B's, so that's good. On S2 we consume A's, we consume B's, so that's good. But you can see S3 here. We don't do anything on A's and B's in S3. Okay? Now, if we did pass in the word AAA to this machine, we shouldn't accept it. Okay? Should not accept it. Okay? We should consume the A, which will take us to S1. Okay? We should consume the second A, which will take us to S3. Okay? But we should consume the third A, but we should not be in a final state. So let's consume the third A by going into this state here on an A. Okay. What about if it was A, B? Well, let's see what's happening. We're going to consume the first A, takes us to S1. We consume the second A, takes us to S3. Okay. But we should consume the B, but we shouldn't be in a final state because this word isn't in the language, so let's take it into this state here on a B. Okay? You can see what's happening here. Let's try the next word, ABA. Okay? When we consume an A, we're taken to S1. When we consume a B, we're taken to S3. When we consume another A, we shouldn't accept, and we're taken to S2. Okay? What about ABB? When we consume an A, we're taken to S1. When we consume a B, we're taken to S3. When we consume another B, we're taken to S2. Okay? So on and so forth. Okay? So hopefully what we can actually see now at this stage is that this particular machine only accepts 3 words. Okay? Okay? Let's pass in another word into this machine. Let's say we pass in B, A, B. Okay? It's not in the language, so it shouldn't accept it, but it should still read it. Okay? So when we pass in a B, it goes from S0 to S2, it consumes the B. When we pass in an A, it stays in S2, but it consumes the A. When we pass in another A, it consumes on S2, but stays in S2. When we pass in a B, it consumes the B. Okay? And then it asks, are we in a final state? We're not in a final state, so it doesn't accept this word. Okay? So this was a little bit more complicated, okay? But the important thing about this machine is that on each state, okay, we consume every character or every symbol that's in our alphabet. Okay. Once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope this video was somewhat helpful.